Okay, so before we go to the first graph that we're going to do today, there's the graphical procedure. Step one, find any vertical or horizontal asymptote, and that also includes slant asymptotes if you see that it has that. We're not going to have that today, so I didn't include that on that. But the very first thing I always do on a graph of a rational function, I see stuff over stuff. I look to see if there's any asymptotes because they kind of create sections where I'm going to graph everything. All right? And I go ahead and graph those immediately too. As I find vertical or horizontal asymptotes, I go ahead and put them in there, vertical line, horizontal line, dashed when you do it. If you have vertical asymptotes, or just a single vertical asymptote, numbers for x near that value would be helpful. So if I, for example, I say x equals 1 as a vertical asymptote, I'd want to pick 0.50, negative 1 to the left of it, 1.52 and 3 to the right of it. That's what I mean by near. Always go 0.5 and then integers after that. That gives you an idea because when it gets to that vertical asymptote, it's coming towards it. You see they're going to go up or down. You want that 0.5 to get that very clear up or down issue. All right. You want to find any x or y intercepts only because they're easy. Remember x-intercepts if y equals 0. All right. In a rational function world, if the top equals 0, the fraction equals 0. So you don't have to do the entire rational function equal to 0. Just top equals 0 to find x-intercepts. Y-intercepts occur when x equals 0, so just let x equal 0 and work it out. Find some additional points. So once you've established the points we want to get, the x-intercepts, y-intercepts, and plus those numbers near the asymptotes. If there is no asymptote, just pick numbers near 0, because those are easy. You know, maybe pick a few decimals here and there. Your calculator is going to be doing a lot of the evaluating for you anyway, so it's not that hard to do. But additional points. You're going to get 5 or 6 points as of right now. Maybe pick 3 or 4 more points on just either side. Or if there's like a big gap, let's say you have an asymptote over here and an asymptote over here, and there's something happening in between, pick some numbers in between. Just see what x values haven't been accounted for. If you can visualize what the graph's supposed to look like, you have enough points. If not, get some more points. Every x you put into your calculator results in a y. Let me get my calculator ready to go too. Now I think about it. And every x, y point represents a point on the graph. So your calculator is going to be finding those for you, so use it. All right. Determine the behavior near the vertical asymptote. That simply means is it going up or down? And if you get your points, and again, here's the asymptote, point, 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 that one's going up. Point, 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 that one's going down. So again, just looking at the points, you can pretty much determine that. And then plot the points, connect them with a smooth curve. At asymptotes, the graph is going to go up and have an arrow on it, or down and have an arrow on it, and it's going to jump across like that. Unlike the piecewise function where we went from a point to a point, we didn't have the arrows in between, but with asymptotes it's going to go up to infinity forever, it's going to go down to infinity forever, so the arrows do go in there. But asymptotes don't get crossed vertically. Horizontal asymptotes can be crossed near 0, but as you go towards the infinities they won't be crossed. All right, so let's take a look. Example 7, determine the vertical and horizontal asymptotes of this and sketch its graph, label all intercepts and asymptotes. They're going to give you some direction sometimes. If they specifically tell you to do something, I want that identified in your answer. The procedure I'm going to use is what I've got there, but it says determine the vertical and horizontal asymptotes. I want to identify vertical asymptotes are, horizontal asymptotes are. All right? And label all intercepts and asymptotes, so that's on the graph itself. You want to label those. All right, so here we go. My function, there should be an equal sign in there. Is there an equals on your paper? No. How about that? Pretend there's an equal sign there, because there's supposed to be. All right, f of x equals 2x squared minus 18 over x squared plus 3. There's our function, our rational function. And if we start off with vertical asymptotes, I'm going to do that right here, VA. All right? Vertical asymptotes occur whenever the denominator equals 0, and those zeros don't create a numerator value 0. Also, just like we did yesterday, x squared plus 3 equals 0. That doesn't happen. Okay, if we can just recognize x squared it's 0 or bigger, right? X squared is a positive number except for 0 squared, which is 0. If we add 3 to 0 or bigger, we're not ever going to get 0. All right, it starts up here, x-axis. So x squared plus 3 can't equal 0, so there's no vertical asymptote here. At no point in time for any value of x will this function ever be undefined. All right. As far as horizontal asymptotes are concerned, what we care about is the highest power term on top and bottom. The highest power term on top, 2x squared, highest power term on the bottom, x squared. And if I do 2x squared over x squared, I get 2. X squareds cancel. So y equals 2 is the horizontal asymptote. That means as we stretch out towards negative and positive infinity, the graph's going to be leveling out at a height of 2. And again, I like to graph my asymptotes as I find them. So y equals 2 right there. The only downfall of graphing the asymptote right away is if you end up scaling things, you have to erase. So maybe even hang on to that graphing the asymptote. I like to graph the asymptote before I start plotting points. I have some pre-knowledge on this one. I know there's not going to scale this one, so we'll be fine. But you know, you maybe hang on to actually drawing the asymptote until you actually do that. So as far as labeling my paper is concerned, horizontal asymptote y equals 2, because again, it did tell me to determine that. VA, there isn't one. So to determine them, there's no vertical asymptote, there's a horizontal asymptote. Again, identifying what they asked me to identify. All right, next, we wanted to sketch this graph. So next thing I'm going to do is find intercepts, right? That's part of that list. So as far as x-intercepts are concerned, the top 2x squared minus 18 equals 0. Fractions only equal 0 if the top equals 0 and the bottom doesn't. We've already established the bottom can't, right? So if the top equals 0, 0 divided by number will be 0. So I don't have to do this whole function equal to 0, just the top equal to 0 will be sufficient. Divide everything by 2, since it's an equation, we're allowed to do that. X squared minus 9 equals 0. So obviously x squared is equal to 9, making x equal to plus or minus 3. So what that tells me is 3, 0 and negative 3, 0 are points. So that's what x-intercepts are. X value is where the y value is 0. As far as the y-intercept is concerned, so x-intercepts are 3, 0, negative 3, 0. As far as finding y-intercepts are concerned, we let x equal 0. So if I do f of 0, I'm going to get 0 minus 18 on top. I'm going to get 0 plus 3 on the bottom. That makes negative 6. So 0, negative 6 is the y-intercept. Again, by identifying some intercepts, I'm getting a few points. All right. And again, I've got some pre-knowledge of this graph. I know we're not going to have to scale it, so we're going to have a one-to-one scale. So, I mean, I can go ahead and start plotting these points right now without any harm. But again, if I'm doing a problem from scratch that I don't have any kind of pre-existing knowledge on, I probably want to find more information before I start the graphing, because if I get a lot of huge numbers, I'm going to want to scale some stuff out. But 3, 0, negative 3, 0, and 0, negative 6. 6. There we go. Those 3 points are on it. And again, all I've got right now is 3 points in a horizontal asymptote, so that's not really enough information to actually connect those dots yet to really see what it looks like. I need to get more information. So obviously, I need to get some values within here. And I probably want to get some values out there because it's not quite reaching this horizontal asymptote, so I'm going to go further out this way too to get an idea. Okay, as far as the horizontal asymptote is concerned, numbers further away from 0 are going to help you establish what's happening there. So numbers like negative 1, 2, 3, 4, 5, 6, 7, 8, 9, negative 9, negative 8, negative 7, these points in here, and positive 7, 8, and 9, those points there will help me get a clearer view of what's going on there. It wouldn't hurt to pick every integer, because again, our calculator is going to be doing the working for us, right? I mean, we found all those points, but if I'm going to find any more points, I'm going to grab my calculator. So y equals, clear out what's in there, and type in parentheses 2x squared minus 18, in parentheses, divided by parentheses x squared plus 3. Go off to my table, delete what's in there. And again, I've got negative 9 all the way to positive 9. I've got a lot of integers there, so that's just picking integers would be sufficient. Negative 9, negative 8, negative 7, negative 6, negative 5, negative 4, negative 2, negative 1. I skipped negative 3 because we already did it, right? And if I did positive 1, 2, already got 3, 4, 5, 6, 7, 8, and 9. Okay. That's probably going to be good as far as points are concerned. The more points you get, the less you have to think about how the graph looks. Again, our calculator is doing all the evaluating for us, so why not pick lots? All right, so negative 9 is 1.71. Negative 8 is 1.64. Negative 7, 1.54. Negative 6, 1.38. Negative 5, 1.14. negative 4, negative 0.74, or sorry, positive 0.74. Negative 2 is negative 1.43. Negative 1 is negative 4. All right, if we put in all these numbers, notice we're getting the same results. Negative 4, negative 1.43, 0.74, just going the other way. So just cross that off and just negative 4, negative 1.43, 0.74, 1.14, 1.38, 1.54, 1.64, 1.71. Notice none of these numbers are reaching 2, or horizontal asymptote value 2. So again, if I pick some huge number, just be crazy, like let's say 250, 1.9996, not 2, pretty close. If I pick 2,000, now it says 2, but it's rounded. It's actually 1.999994, all right? It'll never reach 2. Okay, because again, we're subtracting 18 and adding 3 here. As we get closer to infinity, these are so much larger than these numbers don't matter in the whole scheme of things, but they still cause it to be a little bit less than 2. You know, if you put a big enough number in, the rounding error on the calculator is going to just give it, it'll just say 2, but it really isn't. All right, so I went 2 decimal points on every value because 1.71 and 1.7138, whatever it said, I don't have a good enough eye to tell the difference in the two, so go a couple decimal points when you round in a chart for graphing purposes. 1.71 is close to 2, but not quite. It's above halfway. 1.64 still above halfway by a little bit. 1.54 just almost at halfway. 1.38 just under halfway. 1.14 getting closer to 1. 0.74 about 3/4. Then we got our negative 30, negative 1.43 would be about here. 1, 2, 3, 4 is right there. Same points going the other way. Same heights, I should say, different points. All right. And now it's starting to be a little bit more visible what's happening here. Notice this is going towards the asymptote, it's leveling off. If it doesn't cross by the time you get to negative 9 or positive 9, it's not going to cross. Again, if it crosses, it's going to be right around 0. So the fact that it didn't cross yet tells me it's probably not going to cross. As far as connecting these dots, if I see enough that I can connect it, I'm good to go. If not, pick 0.5, negative 0.5, pick 1.5, negative 1.5. Again, if you don't have enough dots there that you are comfortable that you can connect those dots, stick more numbers in your calculator and get some more points. For me, it looks good enough that it's doing like this. That's that half. Then the other half comes up this way. Connect the dots with a nice smooth curve like that. And there's our graph. If I were to actually hit graph on my calculator with the same window from negative 9 to 9, and a 1 scale, and from negative 6 up to 3, at a 1 scale, hit graph, and compare the pictures. Looks pretty close, right? So that's the way you check a graph. I don't want you to graph it, hit graph, and then just copy it on your paper. I want you to actually plot the points. I want you to follow the process. But if the graph with the same window looks the same, it's in good shape. Keep in mind if your window is some sort of a, like this is pretty rectangular compared to that, so they look almost exactly the same. If this were square and that's rectangular, it can cause some distortion. So don't automatically believe it. But again, you know, based on them being pretty much rectangular, both about the same rectangular position, they look almost identical. That's a good checking tool. Just as if you hit the graph button, you should see a picture that looks similar to what you have, assuming you put in the same window.